the biggest thing that you need to know with radicals or square roots is if you have the square root of something, you can split it up using multiplication. Same thing happens with division. If you have the square root of a over b, you can split it up into the square root of a over the square root of b. So you can split up square roots using multiplication or division. The other thing we need to review is your perfect squares. So the list of numbers that are created by multiplying numbers by themselves. So on the right side of our paper, or maybe on the left side, I don't know which side, we'll put it somewhere. If we list out the numbers that are perfect squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3, 4 times 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. No? If you can memorize that 13 squared is 169, you can memorize 14 squared because you just take the 6 and the 9 and switch them. 14 squared is 196. 15 squared, 225. All right, that is a pretty good list of perfect squares. Okay, we are going to simplify these square roots by splitting them into a perfect square times something else. Because the perfect squares, we can take the square root of without getting a decimal. So 18, think about the square root of 18. Is there a number in this list that we could divide 18 by? 9. So rewrite this as the square root of 9 times the square root of 2. It is very important that you leave the square roots on the numbers at this point because 18 was under the square root, so 9 and 2 need to also be under the square root. The square root is kind of like an operation. Use the square root to change this 9 into something else. What is the square root of 9? 3. 3 is no longer under a square root symbol because 3 is the square root of 9. The square root of 2 would be a crazy decimal, so we leave this as the square root of 2. 3 times the square root of 2. Do you remember doing this in previous classes? Some teachers teach you with factor trees and teach you to find pairs of square roots. I think it's easier just to find the biggest perfect square times something else. So 72.
36.
Okay, some people think 9, but there's a bigger number that works. 36 times 2. The square root of 36 is 6. So what I usually do is I try to take half of the number and start looking for the right number there. So half of 72 is 36, and oh look, 36 is on that list, so I would use 36. So 48, if I use my strategy, half of 48 is 24. 24 would be here. It's not on the list, but since 24 is half of 48, I know 25 is not going to work. I know 36 isn't going to work. We need to go the other direction. So try 48 divided by 16. What is 48 divided by 16? 3. So that works. 16 and 3. The square root of 16 is 4. So 4 times the square root of 3. Okay, number 4 just has a number 7 in it. We have 7 times the square root of 24. We're basically just holding on to this 7. That 7 is not under the radical, so it's a whole number. It's just kind of chilling in front. Square root of 24. What can we split 24 into?
4.
Square root of 4 and square root of 6. And the 7 is in front of that. The square root of 4 is 2. So you have 7 times 2 times the square root of 6. 7 and 2 both do not have a square root over them. They're the same type of number, so you can multiply those together to get 14 times the square root of 6. Let's try number 6 together, and then I'll let you do number 5 on your own. Number 6, there are two types of numbers. There are whole numbers that are not under the square root, and there are radicands. A radicand is a number underneath a radical. It's like 18 and 10 are radicands. They're stuck under the square root. So I cannot multiply the 4 and the 18 together, but I can multiply the 4 and the 3 together to get 12. And because 18 and 10 are both radicands, I can multiply those together to get the square root of 180. When you have multiple square roots, it is typically easier to combine them first and then try to simplify them. So half of 180 is 90. So I would start probably with 81 and try 180 divided by 81. I think that's a decimal, isn't it?
Yep.
180 divided by 64.
Yep.
Decimal. 180 divided by 49. Decimal. 180 divided by 36. 5. And that 12 is still written in front. The square root of 36 is 6. So this is 12 times 6 times the square root of 5. So 72 times the square root of 5. You try number 5 on your own. It's actually a lot easier than it should be. When you multiply the 3 and the 12 together, you get 36. How many of you started thinking about, let's see, so that's 9 and 4. You don't need to break down the square root of 36 because 36 is on this chart. The square root of 36 is 6, so our answer is 12. Let's move into fractions. Some of these are super ridiculously easy. Like this first one. You can split this up into the square root of 36 over the square root of 25. What is the square root of 36? What's the square root of 25? And you're done. This next one, we have the square root of 75 over the square root of 36. The square root of 36 is 6, but what do we do with the square root of 75? We can take the square root of 75 and break it down into the square root of 25 times the square root of 3. So 5 times the square root of 3. That would then go on the top for that one. 5 times the square root of 3 over 6. Okay, number 9. Number 9, we have the square root of 6 over the square root of 5. Can we break either of those down? Okay, now here's the problem. The square root of 5 is an irrational number. It would be a decimal that would keep on going forever and ever and ever. You are not allowed to have an irrational number on the bottom of the fraction. So we have to find a way to make this square root on the bottom go away. So, question for you. If I take a random number like 8 and I multiply it by 1, what is 8 times 1? 8. What is 22 times 1? 22. Does multiplying by 1 change a number? Okay, I'm going to multiply this thing by a unique version of 1. I'm going to multiply it by the square root of 5 over the square root of 5. The square root of 5 divided by the square root of 5 is 1. I'm just multiplying by 1. It's just a fancy version of 1. On the top, square root of 6 times the square root of 5 is the square root of 30. On the bottom, what is the square root of 5 times the square root of 5? 5. The square root of 25, which is 5. And we can try to split up the square root of 30. I don't think that one simplifies at all. There's no numbers on that list smaller than 30, so that would be our answer. This is called rationalizing the denominator. A radical is an irrational number. We are rationalizing. We're getting rid of the irrational on the bottom. Okay, let's look at the next one. 2 times the square root of, 2 divided by the square root of 3. There's nothing to simplify here. The only problem is we can't have that square root of 3 on the bottom. So what do you think we're going to multiply by? Square root of 3 over square root of 3. On the top we have 2 times the square root of 3. On the bottom, the square root of 3 times the square root of 3 would be the square root of 9, which is 3. By multiplying a square root times itself, you're canceling out the square root and leaving yourself with just that number. Another way to think of that is the square root of 3 times the square root of 3 is the square root of 3 squared, and the square root cancel each other out, leaving you with just the number. Okay, number 11, there's a lot going on here. We have the square root of 45 over the square root of 32. I would like you to take a minute on your own, simplify the square root of 45, simplify the square root of 32. Once we have that done, then we'll finish the problem together. The square root of 45 splits into the square root of 9 times the square root of 5, so we have 3 times the square root of 5 on the top. The square root of 32 splits into the square root of 16 times the square root of 2. So we have 4 times the square root of 2 on the bottom. This looks great, except for one major problem. You can't have that radical on the bottom. So what do we need to multiply by? Square root of 2 over square root of 2. On the top, we have 3. We can multiply the 5 and the 2 together because they are both radicands. So we have 3 times the square root of 10. On the bottom, we have 4. The square root of 2 times the square root of 2 is the square root of 4, which is 2. So on the bottom, we actually have 4 times 2, which is 8. So our final answer is 3 times the square root of 10 over 8. Once you get your worksheet, I want you to do the problems on the right side of the page. So the right column of the worksheet, or all of them for bonus. I didn't think I was giving you any more bonus this unit, but hey, I guess I am, because why not?